Mr. Bowers, you know I had a bottom half of my face.
There we go. Is it?
Wait, what? What is that?
There's that.
Wait, what?
Give me a second.
Where's Nathan? Where's Nathan? You gonna die?
No, no. All right. So, that's my little note to myself. All right. If we need to shorten the chapter, just do the problems bold and blue. Beautiful. All right. So the character we're going to be talking about in this chapter is Rolina. Rolina. Hey, you better remember. All right. So that's Rolina right there. All right. It's Rolina. Rolina. Right? Okay. That's the one-eyed lion. Not two-eyed. One-eyed lion. Make sure you. Yeah, the one-eyed lion. That's him right there.
But why is he called the one-eyed lion?
Because he's the one-eyed lion. Yeah, he only has one eye. Yeah.
That's sick.
But that's why Rolina's, you know. All right. So, let's see what we know. Oh, you didn't see that. Guys, let's quiet down. Let's get through some of this. All right, concept example 1. How will the ball roll off the cliff? Do you think A, B, or C?
C. Because it's more there.
It depends. Are you putting any backstory?
The answer is C. All right, the answer is C. That's what a projectile will look like. Looks like a kickball.
Or is it that ball from the
Yeah. All right. So, projectile motion. Here we go. Projectile motion is the form of motion in which an object or particle, called a projectile, is thrown near Earth's surface. All right. We can move in the X. We can move in the Y direction. Under the action of gravity. Gravity. It's working. I don't know the rest of the words. But gravity is negative 9.8 meters per second squared. It's always a good reminder. I was going to create a country song that was Christmas themed that talked about dimensional analysis.
Please do it.
I'm going to do it. I got it working up here. You know, I'm thinking it's. Yeah, for sure. For sure.
Make an album.
Oh, it's gravity is working against me. That's the next thing. It just came to me.
There we go. Now I know. Now I know. For next year. Yeah.
Why does it say that air resistance is negligible?
Because we're not analyzing air resistance when talking about projectiles.
What if you're in a free fall? Then gravity's working with you.
Say what?
I said, what if you're in a free fall? Because then gravity's working with you, not against you.
Okay.
It's just working.
But it's still negative 9.8. So you're falling, so it's still negative. So yes, it's working with you.
Yeah. So then the song's wrong.
I don't think.
Only if you're falling in free fall.
That's
I feel you. I see what you're saying. Yeah.
Well, you see, if you're in free fall, gravity's not working with you.
Are you still going?
Because if you're falling
Are you still
on a
writing?
plane or something, you don't like gravity.
That is true. That is true. All right. So a parabola. All right. We all know what parabolas look like, right? We're all see all those are beautiful. Anybody been to DC before?
Yes.
Beautiful. Love it there. All right. Whoop. All right. So we're going to watch a video here real quick. Watch the following video and think about which ball will hit the ground first. All right. I know my videos don't work. It says watch presentation.
I am in presentation mode. All right. So here's the video. Give it a second.
Goat video.
There we go. Oh, buffering. Okay, so that one fell straight down. He hit that off the side.
He needs some WD-40.
All right.
What?
No. But
What?
What?
Why?
But we didn't.
watch the video. All right. There is. All right.
Okay.
Which do you think is going to hit the ground first? Ball A, that's going to fall straight down, or ball B, that's going to go to the side?
Same time. Same time.
Oh, there's always option C, and it's the same time. Okay.
Option D, the video's upside down, they're gonna go up.
Oh, fast forwarded too much. Hey, get rid of there.
That doesn't look like.
It's not.
Okay. So they all hit at the exact same time, right? That's pretty awesome. Okay. Now, got one better for you. One better. Oh, that's not what I wanted. Mythbusters. Love myself some Mythbusters. Man, my computer is very slow today.
You have 72 tabs open.
Say what?
You have 72 tabs open.
I don't have 72. I should have 72 open.
Gotta get that 30
Yeah,
down.
72 tabs open.
I should have 72 tabs open. All right. So Mythbusters, they do the experiment. They shoot a bullet. Okay. I think someone actually asked if someone shoots a bullet and someone drops a bullet at the same time. Well, they land at the same time.
I think we were talking about shooting a bullet out of a car and the car outrunning a bullet.
That does not seem possible.
What you got there?
Same second, except one the other is fire from the gun. Classic physics stuff. And there, right pick the they done it was play and now it's also so history.
I think we'll hit it on the first.
I'm going to turn down the volume just so no one thinks in other rooms. Did you guys see that? Do they fall at the same time?
Wait. Yeah. Cellular film on the screen. You know that it's made up of that takes 20.
Bada bing, bada boom.
You know what I mean?
That makes more sense.
That's pretty cool.
I think I know how they could have been eating more of us. I love it. Wire going to the thing that drops it, right?
Right.
The signal is dropped. If the electrician takes some time to get it, he's amazing.
Might work. All right. Let us. Oh. All right. So concept. When a ball is being projected into the air, what will the acceleration in the x direction be? Man, why? I don't know.
0.
Last video.
It's been a video run day.
Is that okay?
Hey, we should watch a video where the guy like puts a bowling ball to his head and swings it away.
That's a great video. We're not there yet.
Can we do that?
I mean, if you want. This guy is pretty cool. Fired it straight up.
Since it's only reasonably close.
It's the same guy.
Perhaps it would help if we. Anyway. Take it down. So as I'm going to push this, you're going to push. The gun will be triggered in the middle of the car here. You see how high that will go? The bolt will go. And depending upon how I push it, they may be here or they may be there. Ready? Physics works.
Physics works.
Does it really?
Yes.
That's nuts.
That's crazy. Like, that's why we're here, you know? All right. So, did it accelerate in the x direction?
Because if it did, it wouldn't have gone in the.
Well, your answer is 0, yes. All right. It is C, concept 0. All right. So, summary of projectile concepts. Horizontal motion is always constant. All right. You're going to have a constant velocity. There is no acceleration. Vertical is always negatively accelerating. We already knew that from last chapter or 2 chapters ago. All right. Vertical is always accelerating downwards at negative 9.8 meters per second. All right. The horizontal motion of an object has no effect on the vertical motion and vice versa. The only thing they have in common is time. Time. And that's crucial when solving some of these problems. If you can remember time is equal, you're going to be golden. and remember a lot of other things, but that's the main thing. All right.
What's the difference between effect and affect?
That's one was a verb and one was a.
Affects a verb, effects
The only one I care about is effect because cause and effect. So
Yeah, that one's the noun.
it's the only one I like.
Makes sense.
Oh, God.
All right. Does all that make sense for now? We good?
No, not yet.
Horizontal is always constant. Beautiful. All right. We got to get into Rolina. You don't want to learn about Rolina? We are going to skip a few problems just because I only want to focus on the important problems. But we'll continue the story of Rolina. I don't want to skip that. That'd be silly. Rolina. It's a fun name. Say it, Rolina. Or should I roll the R? Rolina. Rolina.
You could add one.
All right, everybody good? Sweet. All right. The Adventures of Rolina. She is a cave woman in the land of Tilapia. You don't even know. Recently, Rolina's cave family was killed by a ferocious one-eyed lion. I told you. Told you. No. Oh my. Did you hear that last sentence? Oh no. This left Rolina filled with a mix of rage and sadness, which caused her to spend most of her time in the mountains looking for the one-eyed lion and wandering.
Is that a thing in our hand?
A javelin?
Here?
Yeah.
That is indeed an arrow.
It's a vector. It's a vector.
No, it's a javelin. Guys don't even know. It's my javelin.
She's going north to the mountains.
All right, so I'm gonna skip this problem. All right, because it's pretty easy. I'm gonna skip it. All right. If you want the answer, I'll tell you later. But Rolina is practicing her javelin throw. All right, she's practicing a bullseye. All right, in this problem. However, in the next one, Rolina climbs to the top of the mountain and decides to pay tribute to her god Ragar to make an offering. Kind of like Roger. Rolina finds the prettiest rock on the mountain and throws it so that it hits the ground 100 meters away from the base of the cliff. If she is 200 meters above ground, she throws the rock horizontally. With what velocity does she throw the rock? Okay, so I'm going to draw this out real quick. She's on top of a cliff.
You can't see that.
I know. I don't want you to see my drawing yet. All right, she's up here.
We can't see up here.
I know.
All
right. Yeah. So that's 200 meters. And she throws the rock 100 meters that way. Okay. I got my drawing. Let me show you what I got. It's quite beautiful, honestly. Like I can't brag.
Where's the orange hair?
Where's the?
What kind of trajectory is that?
It's not. That's my cliff.
Oh.
That's my cliff. All right. So she has the rock, right? And she throws it horizontally. And it's going to fall like that. That's 100 meters right there. I don't know what that is right there. All right. So I got that. Holy smokes. There we go. Now, this is the tricky part because we have a lot of things to analyze. I'm going to do two different colors. We're going to have the X. I need another color.
Purple. Purple.
How about green?
Yeah, you have a ton of colors.
Okay, X and Y. Okay. So let's talk about the X direction real fast. All right, so she's going X. Now, what's my acceleration in the X direction? Do I know that? Oh, but I do. It's 0. X direction never accelerates. Okay, so my acceleration is 0 meters per second. Okay, beautiful. What's my delta x? How far did the travel x-wise? 100 meters. Very good.
Shouldn't acceleration be 0 meters per second squared?
Oof.
That's
Oh my gosh.
My B. You know. All right. Is that all we know for now?
No.
That's all we know. That's all we know. Let's talk about the y. What is acceleration in the y? Nailed it.
Don't forget the square.
Nailed it. All right. Delta x, or I should say, yeah, displacement in the y direction.
You wrote X. Why'd you write X?
Because that just means.
X means displacement.
What?
Yeah, get wrecked.
Oh, wow.
But it's fine.
Wow, man.
Displacement in the y direction. So technically it would be.
Okay, see, I was like, there should be a Y in there somewhere, shouldn't there?
No,
Change it.
hey,
What is my displacement? Negative 200. Okay. Now, one fun fact. When an object is thrown horizontal, the initial velocity is 0. Right? Because if it's horizontal, it's not going up or down. Right? Immediately, the very, very initial, right when, bless you, right when you toss it, it's 0. Right? Because it's not up or down. You threw it sideways. Okay? So my initial velocity is 0. Okay. Now, there is one unit that both of these share. What is that? Time. I have to find time. Okay? When I find time there, I can use time here. And this is where it gets a little interesting. All right. So if you have your equation sheet, handy dandy equation sheet, right? You don't have to get it out, but it's helpful in this chapter. What we're going to use is the delta. Oh, I have the wrong pen. Delta x is equal to the initial velocity times time plus half the acceleration of time squared. Okay, so this is all my green. Okay, so delta x in my green is negative 200. Initial velocity times time is what? 0, right? My initial velocity is 0. So all I'm worried about is half of negative 9.8 times my time squared. Does that make sense? Okay, so negative 200 is equal to negative 4.9 t squared. Divide that over. I need a calculator. I don't think I can do that in my head. It's probably close to 40. 200 divided by 4. I got 40.8 is equal to t squared. Take the square root of that answer. I got time to be about 6.39.
So it should be 6.4 because 2 sig figs.
We're not worried about sig figs to our final answer. So 6.39 is my time. So if I look over here, my time is 6.39. All right, so the question's asking, with what velocity does she throw the rock? All right, so I got to find my velocity in my x direction. Okay, so I have a lot of data now. So if I plug it in the same equation, what's my delta x? 100 is equal to initial velocity, which I don't know, times time. What's my time? 6.39. Plus half the acceleration. What's my acceleration? 0. times 6.39 squared. So I have 100 is equal to the initial velocity times 6.39. Does that make sense? Okay. Oh, you can't see that. My bad. That's what I got so far. And then you just divide it, right? So 100 divided by 6.39. I got the initial velocity. Now this, or we care about sig figs. Okay, so I got 15.6. This only has one sig fig, so I got to round to my one sig fig. Projectiles, man. Yeah.
How much do we know? How much do we learn to while we're doing that? Before the final.
I usually go to the 100th. If you just want to keep the number in your calculator. Oh, what happened to my screen? It's frozen. It's frozen. Oh, no.
Cole, come back.
It's kind of weird. I don't like it. There we go. All right. So you can just keep the decimals in your calculator. That's fine as well. Yeah. All right. Any questions on that problem? I think we nailed it. Where were we? Adventures of Relina. All right. So she threw a rock to her god. Roger. Right? 20 meters per second. Roger was sleeping and did not notice the offering. How sad is that? That's what I'm talking about. You know what I'm saying? All right.
Where did you come up with that?
Now, we're not going to do this example. We're not going to do this example. Rolina finds the one-eyed lion and starts to sneak up on it. The lion notices Rolina and starts to dash away. Rolina throws her spear and impales the lion. Having no choice, the lion runs off the cliff with a horizontal velocity. Yeah.
Yeah.
Now,
It went through. Yeah. Rolina has a good arm.
How does it go through?
All right. So we can solve all these answers. All right. But it's just like the same problem, same equations. Okay. So we are going to move on. Rolina does not notice the lion resurfacing from the water. However, on her way back home, she notices 3 baby lion cubs, each with only one eye that has not opened yet.
What?
Rolina thinks about throwing each of the cubs over the edge with her mother.
What the heck?
But realizes that wouldn't be very nice, so she readies a pot of boiling water and feeds each of them some pumpkin soup. Gotta be ready. All right, and that is the intro to what we're gonna do tomorrow. All right, this is Rolina. No, we can still hit Rolina. There's Rolina right there. So we are done for the day. All right.
Wait, I'm confused. Was the lion born with one eye, or was it born with 2 eyes and 1 eye?
It was born with one eye. Yeah, for sure.